Game, begin.
Merci. Bonjour Toulouse, je m'appelle Victor, je travaille à JetBrains, and this is everything I remember from my French course from the school. So I will continue in English, and anyway, the talk was announced in English. I'm a software developer, so most of the time I write code. When I don't, I swim, bike, and run, so I'm also a triathlete. And the reason why I'm talking about this is that I want to share a little story with you before we start. So a few years ago, I wanted to register for a race. I don't remember, it was a triathlon or a run. There was an online registration form. You fill similar forms like once a week at least. And I didn't have much problem with this form up until I get to the birthday field. So the race was near Munich in Germany, so it's in Europe. I entered the date and immediately got an error. So it was some weird, wrong month. Okay, I thought maybe the programmer who wrote this page was an American, and in America they write dates like this. So 31st of March becomes 3/31, and well, it worked. So no more errors. I filled the form till the end, submitted it, and got an error this time. It was coming from the server. So the first one was showed me instantly. It was a JavaScript validation, and now there is a server-side validation. What to do? Well, I'm a programmer, and I can fix all the things in computers. That's what at least my mom thinks when she needs to recover her Windows computer after an unsuccessful update. But in this case, yeah, I did fix it. I opened developer tools in the browser and forcibly entered needed values in the input fields. It worked. No more JavaScript errors, no more server errors. I got confirmation email, everything went smooth and good. Yeah, I was proud of myself, but at the same time I started to think, I'm a developer again, and I do similar kind of development. So I create web services from time to time. I do back-end development and front-end development, and I thought that I could ended up in the similar situation. Even if I do everything by myself, I can mix the things if I do it differently on the backend side and front-end side. How to prevent this? Of course, you know the solution is to write unit tests. Well, unit tests will not help in this situation, and probably there were unit tests, but given that there are different parts, front-end and back-end, they were tested independently, and they didn't work together well. Yeah. Writing integration tests is not a solution here either, because well, you cannot write integration tests for every simple feature. Integration tests are usually hard to write, at least hard to write properly. They are slow. This all makes them very expensive, and nobody likes writing integration tests. And well, this is not the case where you need to write integration tests. You need to cover bigger features with this kind of tests. So, how modern applications nowadays look like? They usually consist of many parts, and I'm not talking about microservices here, but you have a server that has some data, and this data can be displayed in a web, on a web page, web browser, but also most of modern applications needed to be to have a mobile client, and you have to major mobile operating systems, so you need to write 2 applications for them. And probably you need to write a desktop application as well, if your application is big enough. And there are 3 major operating systems on desktop. So it is very complicated already. And if we add the programming languages to the picture, there are a lot of programming languages. They are very different in their syntax. And this is only one of the problems. There are many other. They can be compiled and interpreted. They can have static or dynamic typing. They can have manual or automatic memory management. And you cannot be an expert in all these languages at one time. So if you need to write a big application that will cover many systems, many platforms, you just cannot do it by yourself alone with all the existing ecosystem. So what if we could change that and throw away all these languages and write everything in just one language? Okay, it's not a secret. It is Kotlin. It was in the session title and what I will be talking about here. Okay, who knows Kotlin? Who is familiar with Kotlin? Oh, pretty good. So did you write at least simple hello world application in Kotlin? Anybody? Okay, who uses Kotlin in production? Oh, good. Somehow there are many people using Kotlin in production than the number of people who wrote hello world in Kotlin. It's interesting. Okay, never mind. Okay. I don't need an introduction to the language, but still, Kotlin was started as a JVM language, another language for Java virtual machine. It soon allowed it to be run on Android, and after some time it even was accepted as a first-class language on Android. After the first release in Kotlin 1.1, Kotlin JavaScript backend was added, so starting with Kotlin 1.1 you can compile Kotlin to JavaScript and run it in the browser, or maybe in your Node web server, or whatever. And now with the Kotlin 1.3, Kotlin native backend has reached its beta. Kotlin native allows you to compile sorry. Kotlin native allows you to compile your Kotlin code to native bytecode that will be run on the most operating systems natively. So Windows, Mac, Linux, iOS, different ARM processors and embedded systems like Arduino, Raspberry Pi are supported. So now you can run Kotlin almost everywhere. Well, this will be different flavors of the language, but we'll see how we can take an advantage of it just a little bit later. But what are the benefits of using the same language across all these platforms? Well, first of all, you have a single team, and everyone on the team speaks the same language. You program in the same language, and it simplifies knowledge sharing. It even simplifies hiring new people, because you don't need to find people with a specific skill set to fill the need in your team, but you may find more universal experts, or you can change roles in your team more easily. This will allow also simpler full-stack development. So no more situations like I just did my part, like I implemented API on the backend, and everything else is responsibility of that guy who does front end. Well, yeah, it can work, but the user needs or a customer needs a complete feature. It doesn't work for user if you implemented an API in backend and you don't have any user interface for this feature. if you write all the application in a single project, in a single language, it is much easier to create the feature from scratch, from all the parts of the feature just by one developer. At least if we are speaking of simple features. Of course, there are some complicated cases, difficult situations on different platforms that need some specific knowledge to resolve. And also, single team makes it easier to deploy on different platforms. So you don't need to wait for other, like if you implemented the feature in Android, you don't need to wait for iOS guys to do this because the feature is already there. You did all the work. And you can release applications for all platforms at the same time. But even better, you can share the code between the platforms. You can share your data structure, so when you add some new field on backend, it will immediately be available on the front end. No more typos, no more forgotten flags, fields, whatever. You can share business logic between the platforms, so like this date validation. You can write it once and reuse in all parts, and at least it will work in the same way. There might be bugs still, but at least they will be the same on all platforms. And you can write tests for this business logic only once and hopefully catch all the bugs. So how to do this in Kotlin? With the Kotlin 1.3, well, initially, multi-platform projects in Kotlin were released in 1.2, but with 1.3 they made a significant step forward. And I will show you how to use them, but first I need to make a small disclaimer that it's still an experimental feature in the language, but we consider experimental not something unstable or something that can be just removed from the language in the future. Instead, we consider experimental as a new feature that we want to show to users sooner, to collect feedback, to test the feature on real use cases, and maybe modify accordingly. We can change something, we can improve, like somehow change the design of the feature. A similar process was applied to coroutines in Kotlin, and if you heard about this feature, it was released with 1.3 after being in development for more than 2 years. And just before the release, some ground concepts of the feature were changed to accommodate the real-world use cases. And it's now much better than it was in the beginning when it was first released. So we hope the same will be, multi-platform project will benefit from the same process of making the feature first available as experimental and then releasing it a little bit later. So how does this work? Well, you probably remember, like 20 years ago, Java suggested an approach, write once, run everywhere, where you compile Java to a bytecode and then run the same bytecode on different platforms. It didn't work really well, because we don't see such applications right now. And with Kotlin, we tried a different approach. Instead of sharing the same bytecode and trying to run it on different platforms, we take advantage of the beautiful feature of the Kotlin, which is interoperability with the outer world, with existing ecosystems. One of the I think one of the points of the success of Kotlin on JVM was that it allowed to use existing Java libraries from the very beginning without any issues. And it also does the same with JavaScript. And with multi-platform projects, you write your code that will be shared between the platform in a common module. It should be a pure Kotlin code And if you need any third-party libraries, you can depend on them, but they should be pure Kotlin as well. And then this common code combined with the platform-specific code from the platform-specific modules to produce platform-specific, I don't know, class files for JVM, JavaScript files for Java, for web, and native code for native. So the candidate for common code in this example would be this validate function. Well, it accepts 3 integers, and in the very simple example, we will just check that month is correct, the thing that bite me in the example. Well, this is a very simple check. It will not be sufficient for a real-world use case. So to implement a better check, we create a date class, pass these parameters to the class, and for example, there is method isValid. Well, I said that Kotlin integrates well with the existing ecosystems, so probably I don't want to re-implement this date class for each platform, or I don't want to implement it in a common code. I want to reuse existing solutions. How do I do this? Well, one of the obvious solutions would be to make it an interface and create an implementation for each platform. There are some issues, though. First, you need to remember to create implementations for all the platforms, and once and only once. Then, in the first example, I created a date class via constructor. You cannot put a constructor into interface, so you need to create some factory, re-implement it, put the logic related to all the platforms there, and you will soon end up with the Java, just in a different syntax. Instead, in Kotlin, in multi-platform projects in Kotlin, there is a new keyword, expect, which marks a class in a common code as expected. It doesn't have any body. Well, it can have properties and methods, but they don't have implementations. And all the implementations are put into platform-specific modules, exactly one implementation for each platform. With expected classes, you can have a constructor on your class, so it will be created transparently without any need for factories. Expected classes have most of the same limitations as interfaces. So, for example, you can have a constructor, you can have a property, but you can't have a property in a default property in a constructor. So it's not allowed because it's a kind of implementation detail, but this is perfectly allowed. You can have private properties because, again, it's a kind of implementation detail. You don't have implementation in expected classes. And you cannot have default implementations for methods as well. But this is just a minor implementation. So in Java, they did default methods in interfaces. In Kotlin, there is already a feature that allows to do the same. You can create extension method on an expected class, and it will just work. So you put it into common code, and it will be available from everywhere, just as usual with extension functions. So the limitations are just minimal, but the ability to, for example, declare a constructor is, I think, it's a huge benefit, and it's very convenient to write common code in this way. Well, here it becomes a little bit verbose. You need to mark as actual all the implementations in platform-specific modules. So when you implement, you need to mark a class as actual, constructor as actual, and then each method as actual. Well, that's to simplify compiler's life. But other than that, everything will be just as usual. And yeah, well, we re-implement it. We'll get back to implementation later. But what else is very important here is that compiler or Gradle plugin will check that each platform has its own implementation of actual class, and everything is implemented there. So you will not end up in a situation where you have two implementations for one platform and no implementation for the other. And the actual classes and expected classes are matched by their fully qualified name. So that's the only requirement. All the names must match. There is no overhead. So for example, this is a bytecode for date class on the JVM, and you will not find any signs of Kotlin multi-platform projects here. It looks just like any regular Java class. Compared with interfaces, for example, there will be some other things mentioned there. And this also, so you can, for example, reuse this class in any Java code if you have any. It will just work as expected. And also, given that we don't have any Kotlin multi-platform specific stuff here, we can make use of existing Java classes. So for example, if we like an interface of API of some class, we just need to reuse it in different platforms while using existing implementation on the Java side, we can declare expected class with all the required methods. So I want to use java.time.localDate, and I need length of year, for example, from this class. I don't care about other methods. I declare it as expected class, make actual classes for example, for JavaScript. And on JVM, I just put a type alias for local date to java.time local date. It will just work. It will transparently replace all the local date usages in JVM, in Java part of the project with java.time local date. Similarly, testing framework was implemented for Kotlin. We have expected annotation in common module, and we just delegate everything to JUnit on JVM and provide different implementations for other platforms. So how does it work? How does it look like in configuration? The only supported platform at the moment is Gradle, and this is the part that changed significantly compared to the previous releases of multi-platform projects. There is a new plugin, it's called Kotlin Multiplatfom. You declare a single project as compared to the previous approach with multiple projects. Now you declare a single project and define targets you want to target in this project. For example, I want to create implementation for JVM, JavaScript, and I run Linux, so I will create an implementation for Linux. There are presets with all the needed settings. You can dig in, but in most cases it will not be necessary. If you use the same names, you just omit them. And then we need to declare source sets for each target. There are two predefined source sets, common main and common test, for production code and for test. And similarly, there are two source sets per target for all the platforms we want to target. So we will have source code just like that. So I mentioned testing already quite a few times. Let's start with it. We put date test class. We mark it with a test annotation, like from Kotlin test, as I described earlier, and just write a simple test that will validate that will check that we validate date correctly. And if you can run in IntelliJ with the Kotlin plugin, you can run this test right from the common code. The only not implemented yet part would be that it will only run on JVM. It will not run by default on the different platforms. From the user perspective, this is, I would say, the only user-facing problem right now in the multi-platform projects in Kotlin in its support, and it's not in the language or libraries. It's just in the tooling. So hopefully it will be fixed soon, and we will be able to run all the tests from IntelliJ just as usual. But now, to run a test, for example, for native target for Linux, I go to terminal and just invoke this test via Gradle. Testing framework for native projects is built in, so you don't need anything. With the JavaScript projects, it's a little bit cumbersome right now. You need to install some modules from npm. You can easily find the instructions how to do this, but it's not the thing what I want to show right now. It's not yet ready. We'll just say this. But all the code is compiled and it can be run, and you can check all the tests on each platform just with some additional steps. So let's get back to Gradle. And as I said, in common module, you can only use common dependencies. So there is a special artifact, Kotlin standard lib common, test common, test annotations common, and anything else you want to use, but only pure Kotlin code. Similarly, the dependencies for different platforms will be platform specific, so we will use, for example, standard library for JDK8 on Java and JUnit. And on JavaScript, there is a Kotlin test JS, for example. However, it requires additional modules from npm. This is an integration with existing ecosystem. And to reuse our newly created common module from other projects in your solution is you only reference it by name, like with all other dependencies, and the compiler plugin will detect correct implementation, platform-specific implementation, and will reuse it. So there are a number of existing multi-platform libraries. Kotlin test, I've already told about it. Coroutines, you can also write coroutines on JavaScript and in native, it just works. There is a serialization library. Again, one of the less known but powerful features is it is again in experimental mode right now, but it allows you to serialize your data classes to JSON, protobuf, and some other frameworks. It is easily extensible, and it does not require a reflection to run. It is all the serializers are created by a compiler plugin, so it just works on all platforms, including native, for example, where you don't have any kind of reflection. You can write also your own library. It will be just as easy as I have shown. And to publish it, you do it like with any other Java library. There is a Gradle plugin, Maven Publish, and then you can either publish to local Maven, to Maven Central, Bintrate, JCenter, wherever you want. And compiler will do everything, Gradle plugin will do everything for you. And then you can reuse this library in another common multi-platform projects or in platform-specific project as well. Everything will be resolved correctly. So let's take a quick look on the implementation. So yeah, we put a lot of actual keywords here, and then we'll use existing Java calendar class this time. the same actual class, but for JavaScript, and here we will use moment library. This is what I think the biggest advantage of the multi-platform projects. You reuse existing classes, you don't need to re-implement them, and here you can transparently integrate with the existing frameworks. You cannot put platform-specific getters, for example. You cannot create moment object in required for many JavaScript frameworks in common code, but you can create, for example, extension method on this class in JavaScript part of the project, and then get the moment object from the Kotlin object, and thus you can integrate with any existing, I don't know, UI components or other libraries you need to integrate with other APIs. To use this, this is a little bit different topic, mostly related to JavaScript. These are specific keywords and markers for JavaScript, Kotlin JavaScript backend, but in Java, in JVM world, Kotlin just integrates with everything. You don't need to do anything. With JavaScript, it's a bit more complicated because JavaScript is untyped. But if there are no types there, and Kotlin is statically typed, you need to provide some types, so you need to write some interfaces manually. So here we will just create an external interface for moment library. We again will, similarly to expected class, we only mention only needed methods from this interface, and function, usual way to create objects in JavaScript to create this object, and we will mark it as defined externally, and it will just be compiled without body. It will just call existing function. So this is as simple as that. You can integrate with the moment.js library to validate that the date is correct. However, when I was preparing this presentation, I still made a bug in this simple validation code. And can you spot the bug here? Yes, please. Correct, correct. I put day, month, year in one order, in validate function, passed to date class, but for unknown reason, I made it in a different order in the date class. Well, this kind of bug can be easily catched with unit tests, and well, after first try, I did notice the error and fixed that. But again, it's a kind of thing that should be prevented from happening at all. So you don't need to think about it. It's not the same integers. Like we kind of need typed integers for this use case. And this is what is available in Kotlin 1.3, and it is called inline classes. Again, it is available on all platforms, on JVM, JavaScript in native, and you can write it in multi-platform common code. So inline classes allow you to inline class with a single property. So there is no overhead on this class. In the resulting, I don't know, bytecode for Java or JavaScript code, there will be only integers, but the Kotlin code will be typed, fully typed. Everywhere where you, for example, need a year, you will need to pass an object of type year. But a compiler will reduce unnecessary object allocations where possible. And it is in most cases, unless you use some interfaces, for example, and pass the inline classes as supertypes. But it's not interesting for our example. So we will I will rewrite the validate method with these inline classes. It is now accepting not 3 integers, but day, month, and year. And the date class accepts day, month, and year. I cannot mix them now. The compiler will detect it. And this is what happened when I did this and opened the test I wrote. So I cannot mix day and month anymore. So the whole problem has gone. I don't have this problem anymore at all. So what we've learned here is that with the multi-platform projects in Kotlin, you can write once and reuse everywhere. Not the same as with Java. You write code and compile it to different platforms and reuse existing ecosystems there. You can integrate with existing libraries and to reduce the amount of code you need to write by yourself and transparently integrate with them. You probably all know this from Java, but it works with the JavaScript and, for example, C libraries and Objective-C frameworks in Kotlin native. And we can use all the language features on all platforms and benefit from them. So, with Kotlin multi-platform, this will not happen at all, because we could have prevented it from the very beginning, and in the cases where we could not, we will write it only once and test it, so we will be sure that everything works fine everywhere. So if you want to learn more about it, this is the link, Kotlin/multiplatform. The samples of my project available on GitHub. There are some complicated cases in configuration, in Gradle configuration covered in the project from one of the Kotlin compiler developers, and it's the second link. There are a lot of crazy stuff there, you can check it out. But in most cases you will not need it. Just create a number of targets and source sets for them. And that's it. So thank you very much for attending. We can have a question and answer session here, but I will be available on the office hours booth and will be happy to talk with you about Kotlin, not only about multi-platform, about everything you want. Thank you.